I want to talk about constant rate jobs. When you want to do a problem involving a constant rate job, you're making two assumptions. The first assumption is if it takes T hours to do a job, then 1/10 of the job is done an hour. 1/10, that sounds really weird. In other words, if it takes me 3 hours to do a job, in the first hour I do a third, in the second hour I do the second third, and in the third hour I do the third third. So in other words, I'm not speeding up or slowing down. I'm going at a constant rate. That's why we call it constant rate job. The second assumption that I make is that when more than one person works on the job, their efficiency doesn't decrease or increase. Like, for example, I used to be a stock boy many, many years ago, and we would unload trucks in the morning before people came in. And to unload a truck, if this was the truck, we would set up a conveyor belt, and one person would stand down here and put boxes on the conveyor belt and push them down, and the next person would stand at the end of the conveyor belt and take those boxes and sort them on pallets wherever they were supposed to go, to whatever department they needed to go to. Now, sometimes I would get to work early before everybody else, and my boss would have to stand at the front door and let people in, so I would start unloading the truck myself. So in that situation, I would load up the line, and then I'd have to stop to run down to the other end and unload the line, and then I have to run back and push more boxes down the line. This is an example of one person being less efficient than more people. Okay, and I think that's pretty easy to understand. For some jobs, it's harder if you have fewer people to do the job. For example, if you're going to do some roofing, one person is less efficient because that one person's going to be climbing the ladder more, whereas if you have two people, maybe one person could hand things up to the other and save climbing up and down the ladder. Now, you're probably thinking, okay, I can understand having fewer people makes you less efficient, but how can having more people make you less efficient? Well, think about mowing the lawn. If you have two people mowing the lawn, but you only have one lawnmower, is it really any better to have those two people mowing the lawn? It's kind of like, unless the lawnmower is really heavy and they can't push it with just one person, having two people mow the lawn with one lawnmower does not increase efficiency. It's actually less efficient because two people are wasting time doing a job that one person could do in the same time. So, we want to, whenever we do these problems, we want to assume that if another person's helping out, it doesn't make the job easier or harder than it otherwise would. May or may not always be a valid assumption, okay? So let's look at this example, and this example is about mowing the lawn. It says it takes you 5 hours to mow the lawn, and your sister does it in three. I don't know, maybe she does it for free. I don't know. Maybe she doesn't get paid. Who knows? Okay, but how long will it take you working together? Well, let's make a table, and this table I won't make as nice as the other one. I'm just going to make a quick table. And we need a row for you, and we need a row for your sister, and we need a row for the totals. Whoops, oh no, that's really bad. I should have used my ruler on that. I didn't, but let's see if we can fix that a little bit. Let's just get rid of it. Okay, so I fixed it. My columns here, with these constant rate problems, I usually will have a column for times and rate. And it is important to make a table because depending on how the problem is worded, sometimes you have different information, and sometimes different boxes here will be left blank initially. So, the time that it takes me to mow the lawn is 5 hours. So in 1 hour, I have done 1/5. The time it takes my sister is 3 hours, so in 1 hour she has done 1/3. And the time total that it takes us, we don't know, so we call it X. And in 1 hour we have done 1x, which is really hard to say. It makes you sound like there's a problem with your teeth. 1x. 1x. I don't know. I always hate saying that. Okay, now the other thing to remember about constant rate problems is that rates add. So 1/5 plus 1/3 equals 1x. Rates add, not time. So be careful. It is not true that if it takes me, 5 hours to do a job and it takes my sister, then together it's going to take us 8. In fact, if you say that, it doesn't even sound right. Why would it take more time if you work together? But rates do add. So I get 1/5 done, plus I get 1/3 done. Altogether, we get 1x done. You can find a common denominator here or use a calculator if you want to, whatever you want to do. I'll just find a common denominator and add these. And I get 8/15 equals 1 over x. And then you can flip both sides. You get x equals 15 over 8, which if you write that as a decimal, 15 over 8 is going to be 1.875. Now, what you can do here, since this is hours, because our rate was rate per hour, so our final answer, the time will be in hours. Since you don't want to sound like an alien or something, we don't normally talk about 1.875 hours. So what I would do is, I don't have one whole hour here. 1 hour is 60 minutes, and I have 0.875 of those 60 minutes. So basically, I take 60 times 0.875, and that's going to give me 52.5, and we will round up to 53 minutes. So altogether, it takes me 1 hour and 53 minutes, and I should round up there because, I'm not going to be done if I round down to 52. I won't be done in 52 minutes. I have to round up to 53, especially if, mom's coming to check and make sure that I did the job and got it painted right. I don't know why I said paint. Oh, because I'm going to do a painting problem eventually, and I'm kind of excited about it. So hope you were excited about this one, and you need to go out there and mow the lawn now.